and welcome to lab number 1 for human A&P 1. So human A&P, human anatomy and physiology. Anatomy, literally meaning to cut apart, is the study of structures. So we're looking at human structure from the gross, the eye level view, all the way down to the microscopic. Physiology is the study of how things are going to work, how things are going to function. All right, let's get to it. Now, in order to begin, we got to have a standard frame of reference. That standard frame of reference is called anatomical position. So if we look at this lady here, she is facing forward, she's standing up, feet are level on the ground, shoulder width apart, her palms are facing forward. This is basic anatomical position. And this is her from the front, this is her from the back. Basic anatomical position, all right? Looking at her from her anterior or ventral side, and then her posterior or dorsal side. Now bear in mind, she, like you, like me, we are bipeds. So if we contrast that to this okapi here, is a quadruped. His anatomical position, or hers, I can't tell, and it's going to be different than yours and mine. Just bear that in mind, especially when we're working with animals in dissections or that sort of thing. All right. Again, anterior, ventral, towards the front. Posterior, dorsal, towards the back. Notice the palms are anterior. Now, no matter which way you turn your hand, your palm is always anterior. Your back is always posterior. All right? These terms are absolute, so don't forget that. All right, compare that to my okapi here. Okay, his anterior is where his head is, but in him, because he's a quadruped, not a biped, ventral is different. Ventral literally means belly side. So for us, if I go back for a second, anterior in the front and ventral, belly side, same thing. All right, but for our okapi, belly side is down here, so ventral's down here, but anterior, where he's walking, where he's looking, is over here. Similarly, here's posterior back here, where his butt is, and then dorsal, where his back is, opposite of ventral. Okay, let's keep going. We got some more basic anatomical terms to deal with here, all right? Superior and inferior. These are relative terms, which means that you got to compare one thing to another. So for example, his eye is superior to his nose. All right? His belly button is inferior to his sternum. All right, you got to have a comparison in there. Let's do some more comparative terms like this. Oh, there we go. Another set of comparative terms are medial and lateral. Now, to understand these, you got to imagine a line going right up the middle of the body. It's called the midline. If something is closer to the midline, it is medial. Let's give an example there, okay? The eye is medial to the ear. In other words, the eye is closer to the midline than the ear. Similarly, the ear is lateral to the eye, meaning the ear is farther from the midline. And again, these are comparative terms here. Okay, the limbs. Arms and legs are the limbs, they're the appendages. They get some special terms, proximal and distal. All right, so the arm here attaches to the trunk here at the shoulder. The leg attaches to the trunk at the hip. If something is closer to the attachment point, it is proximal. If it's farther from the attachment point, it is distal. Okay, for example, the elbow is proximal to the wrist, meaning the elbow is closer to the attachment than the wrist is. Flip that around. The wrist is distal to the elbow, meaning the wrist is farther from the attachment point. All right, excellent. Moving right along. do me a favor here. Figure out on your own the relationship between President Obama's palm and his elbow. The palm is blank to the elbow. Then flip it around and say the elbow is blank to the palm. Let me know what you get. Okay, more comparison terms. Superficial, if something is closer to the surface. Deep, if something is farther from the surface. So, the muscles are deep to the skin. The skin is superficial to the muscles. Easy peasy. Now let's slice the body up, okay? Remember that line, that midline that we had going down the middle of the body? If we imagine slicing the person through that midline, that kind of cut will be called a longitudinal cut because it's on the long axis of the body. All right? Notice we could do a longitudinal cut two ways. Kind of a left-right cut, or, as illustrated by this purple, whatever this thing is, rectangle, square, a front-back cut. Those are both longitudinal. If we go across the body, that is called a transverse cut. All right? Now notice when we separate left and right halves, we call that sort of cut sagittal. When we separate front and back halves, we call that sort of cut frontal, also known as coronal. And we'll come back to these. Okay, like I just said, two types of longitudinal cuts. Left and right creating cuts. That's a sagittal cut. So if you get a left versus a right half, that's a sagittal cut. If you get a front versus a back half, that is a frontal or a coronal cut. All right, check out this skull here, looking at the top of the skull. This joint here is called the sagittal suture. See if you can figure out why it's called the sagittal suture. Meanwhile, this joint here is called the coronal suture. See if you can figure out why it is called the coronal suture. And while you're at it, tell me why these joints are so back and forth, back and forth, back and forth, back and forth. Why not a straight line? Do that too. Okay, look at this heart. This heart was cut, giving you a front portion and a back portion. We see the back portion here. So what kind of cut was that? Think about that. All right, there's actually a special kind of sagittal. So remember, sagittal creates left and right pieces. Special kind of sagittal creates, as best as we can, a perfect left and right half, like right down the middle. Although obviously we're not totally symmetrical. But this attempt at a perfect midline cut is called a mid-sagittal cut. All right? If we go to any other cut that's still sagittal, and there's an infinite number of these are parasagittal. So they give us a left and a right, but they're not exactly going to be equal. And we know that. Okay. Moving right along. I think we're almost done. We're almost done here. This is the last one. Some organs are tube-shaped, like the intestine, the trachea, the esophagus. Because a tube has symmetry based on its circular nature, it's got radial symmetry, you can't really have frontal or sagittal. I mean, you can have longitudinal cuts. I mean, a longitudinal cut would go whoosh, but then the two pieces would look just the same as if you were to cut it frontally. So keep that in mind too. That is it for lab number 1. See you later.